Well, welcome back, everyone. In the last lecture, I introduced the idea of an experiment, saying the investigator decides whether the person is going to receive one treatment, a new treatment, or a standard of care. I introduced the notion of a randomized controlled trial, saying that the investigator assigns treatment using some randomized device like a coin flip to decide which treatment arm a person is going to be assigned to. What I'd like to do now is link what I said then, link the randomized controlled trial to what we've been talking about previously when we talked about the true causal effect of a risk factor on an outcome. So to build the argument, let's review what we talked about before. If I really want to measure the true causal effect of a new treatment, basically what I'd like to do is enroll a group of people and assign them all to receive the new treatment, follow them over time and see what outcomes happen among those people, and then somehow, say by putting them into a time machine, bring them back to the point in time when they were given that new treatment, but now deprive them of that new treatment, give them a standard of care or give them no treatment, whatever hypothesis you're testing, and now follow them again forwards in time, measure their outcomes under the scenario that they did not receive the new treatment. So essentially what measuring a causal effect means conceptually is that we're going to compare the outcomes, the counterfactual outcomes, two different outcomes that can happen to an individual under two different scenarios. One when everyone is given the new treatment, and one when everyone, the same individuals, are given the standard treatment under identical situations, as if you could go back in time and repeat what happened now under the situation where they no longer were given the new treatment but were given the standard of care. Now, this is a little diagram that describes what we'd love to do. We have a group of people. We want to measure the effect of this new treatment on those individuals. I'd like to measure their counterfactual outcomes, which are represented by these two boxes down the bottom. The first situation is when everyone is given the new treatment. Everyone in our study receives this new treatment. Everyone's followed over time. All those outcomes are measured. And then what I'd like to do is put these people back into the time machine and now look at the situation when they're not given the new treatment but the standard of care. Conceptually, that's what I'd like to do. Now the problem with this conceptual idea is it's not practical, because the problem is I can only measure one of these counterfactual outcomes on any individual. I can either give you the new treatment and follow you to see what happens to you, or I could give you the standard of care treatment and follow you and see what happens to you. I don't have time machines. I can't bring you back in time so that you were given both treatments under identical situations. Well, although I can't do it for an individual, I can do it at least in an estimation level for a group of people. So the solution is going to try to estimate these counterfactuals for groups of people. Estimate what would happen to this group of people if they were given the standard of care, and estimate what would happen if they were given the new treatment. Now, this is where the randomized trial comes in very nicely, allowing us to get these estimates of these counterfactual outcomes so we can estimate the true causal effect of a treatment. And the way we're going to do this is the following. When I randomize people to two groups, the group that received the new treatment are essentially a random sample of everyone I started out with. Remember, let's suppose the investigator has a coin that he or she is using to assign people to either the new treatment arm of this study or the standard of care arm of this study. Every time the coin comes up heads, a person is assigned to the new treatment arm. Well, essentially, everybody has a 50% chance of being assigned to that new treatment arm. So the people who fall into that new treatment arm are essentially a random half, a randomly selected half of the original population. When I measure the outcomes, instance, among those people who were randomized to receive the new treatment, I'm measuring in a random sample of my original population. The observed outcome incidence among my randomized people is going to estimate what would happen to everybody in my study if everyone was given the new treatment. And on the same argument, we can talk about the other half of the people who were assigned to the standard of care. That's also a random sample of my original population. Their outcomes and their incidence of those outcomes is an estimate of what would happen to everybody if everyone was given the standard of care. So the same argument holds true for those who are randomized to the standard of care. So in this randomized controlled trial, what I'm observing are two random samples in my population, both of which are providing me estimates of what would have happened to my entire study population if everyone was given the new treatment or everyone was given the standard of care. Now that idea is displayed in this following picture. This top box, let's suppose it represents everybody who's in my study. And what the investigator is doing in the background is he's flipping coins. And every time a coin came up head, that person was assigned to the arm of a new treatment. So this shaded red subgroup here represents the random sample of the population that's assigned to receive the treatment. Their outcome, their cumulative incidence, their incidence rates, however you're quantifying, is an estimate of what would happen to everybody if everyone received the new treatment. On the same idea, if I go back to my original population and just look at the subgroup of people who were randomized to receive the standard of care, the unshaded box, their incidence rates, their cumulative incidence, will be an estimate of what would happen to everybody if everyone received the standard of care. So the outcomes that I measure in these two randomized groups, randomized to receive new treatment versus randomized to receive standard of care, estimate these two counterfactual outcomes for the entire population in my study. That's the nice feature of randomized controlled trials. So basically, when I collect my data and measure the incidence or the cumulative incidence or the incidence rate of the people randomized to receive new treatment and compare it to the cumulative incidence, the incidence rate of those randomized to receive standard of care, I come up with a measure of association, a risk ratio, a rate ratio, an odds ratio, things we've been talking about already. And because these are random samples and because the incidence rates, cumulative incidence, odds that are measured in each randomized group estimates what would happen to the entire population if everyone received treatment or everyone received standard of care, these measures of association from RCT should estimate very well the true causal effect of a risk factor on an outcome. That's why we epidemiologists do randomized controlled trials. They are the ones that are most likely to give us the best answer, the true effect of a risk factor on an outcome, because measures of association from randomized trials should estimate very well true causal effects of risk factors on outcomes. So what we're going to be doing in these randomized trials is we're going to take everybody and randomize them to receive either a new treatment or to receive a standard of care. These are two separate groups of people. We're going to compare them using the standard measures of association we've talked about, risk ratios, odds ratios, rate ratios, and interpret those as valid estimates of the true causal effect of the treatment, the new treatment, on the outcome. Well, that's the link that I want to talk about with what I've said before. When we come back, I want to give a series of lectures on the different components of a randomized trial, trying to give you more ideas of what goes into this particular study design. I'll see you then.